Hey guys, welcome to a new video in this QLearning project that we're currently doing. In the last video we talked about the kind of like the description of the project and how to set up the project, and we also talked about some of the different kind of elements that are in the project and we need to give out different kind of states, markup property, and we also talked about like the epsilon greedy algorithm that we're going to take. So we have like a trade-off between exploration and exploitation in the environment when our agent is trained, and also when it is deployed in the environment after training. So first of all, remember to hit the subscribe button and bell notification under the video, and also like this video if you like the content and you want more in the future. It really helps me and the YouTube channel out in a massive way, so I'm just really thankful for your support. So let's jump into the code here and see like how we can actually implement the project that we have talked about in the previous video. So first of all, here we have our main program where we have a class here with the QLearning where we're going to do all the functions and all like the learning and training processes. So first of all, here I'm just going to give you an overview over what different kind of things we have in this project and what it contains, and then what we call in our main function to actually like train and deploy our agent. So first of all, here we have like a class here where we create an object of that class, and then in the constructor here we pass the number of episodes that we want to train our agent on. So in this case here we just have 5,000. We can also set it to 10,000 or 20,000 or whatever we want to, and the number that we want to train our agent on. So it really depends on the results that we get from our training, and also when we're testing different kind of parameters, like how fast is our agent learning, does it need more episodes to learn over, and stuff like that. So this is also a parameter that we can tune when we're playing around with the parameters and also testing the training process and when we're deploying our agent. So first of all, let's go into the header file here and see like what different kind of functions we need to implement to get this QLearning project working, and also like how we can have this agent in operating in the environment or interacting with the environment, and then taking some action depending on the state and receiving some different kind of rewards and stuff like that. So we're going to go over all about this in this video here, and also in the next video that I'm doing. So I'm splitting this code and test section up here into two. So remember to hit the subscribe button so you will get a notification, and you know when I upload the next video. It will be in the upcoming days as well. But first of all, here we're going to have a structure here of the room. So I talked about like these rooms here are the states, are like the states in our QLearning here or in our reinforcement learning project. So first of all, here our room has like a room number. So we have these different kind of rooms in the environment, or like the map that I showed you in the slide where we have the rooms from 0 to 10. So it will have a room number here, and then we will have this boolean here because we need to give it a markup property. So each room or state needs to have some memory where it contains like if it has been visited and stuff like that, because we need to know that for our agent to learn that it should not re-enter or get stuck in between rooms and just going back and forth between two rooms. So we need a boolean here to tell if the room has already been visited, and a room also contains a reward which we'll set in the CPP file here for the QLearning. So this is just to set it up and set like an individual reward for each room. So this is the predefined reward as I showed you on the map that we're going to initialize our room with here. And then we also need to know like the number of visits the room has had. So how many times has the room been visited already, and we also need to know like how many actions can we take from the given room that we're in, because in the map some of the rooms were like in an end room, so it only had like one action where when the agent is, for example, in room 10, it can only take one action, and that is to go to room 9. But if the agent is like, for example, in room 5, then it had multiple and like around 5 to 6 different kind of actions that it can take. So we also initialize it here with a number of actions that we can take for that given room that we initialize. And then we have this constructor here which just initializes each room with the reward, and then we can set these other parameters here later on when we're doing the training process. So if we go down here to the actual like QLearning class that we're going to implement, we have this constructor here, the default constructor, which we're not going to use in this example or in this project here, but we use this constructor here which is initializing the number of episodes that we want to train our agent on. So the parameter which pass here, we just set this to the member variable, or like the member attribute episodes down here, so the number of episodes that we want to train our agent on. So we start with going down here to like the private member variables, or like our member attributes first. We first have a Q table here where we're going to store all the Q values that our agent is going to learn while training. So we talked about some of these things here in the previous video, and it's important that you watch that video before, because all of like the setup and the different kind of elements and how we're going to approach this project, I talked about that in the previous video. So that will, if this doesn't make sense, and you might need to like go to the previous video and watch this and then come back to this one and see like how we can actually like implement what we have talked about in the previous video. So we also need a QTable here for when we're deploying our agent, and the reward matrix here, which is just like the different kind of rooms, that we're going to have in this reward matrix, and the predefined reward that we have from each room. And then we're going to set up that the reward matrix gets a negative reward, so it can't go from one room to another room if there's no connection between them. And then we're going to have a vector here of just all the rooms that we have in our environment. Then we have some different kind of variables or attributes here with the max received reward for each episode that it's running. So we're going to store the max received reward in this attribute here. This is just, right now I'm just going over the different kind of attributes and all like the variables and parameters here, but we'll go back to these when we're going to use them in code as well. But this is just to give you an overview over what the different kind of elements in QLearning when we're doing this project contains. So we also have the number of states here, which is 11, because we have like 11 rooms in from 0 to 10 in our environment. And then we have an initial state, and we also can give it an initial random state. So this is just to give it an initial random state when we start each episode. Then we have the different kind of parameters here, which we're going to use in our Q function, and also show you these parameters here in the Q function and in the previous video. So we have this gamma value here, which is the discount factor, and we're going to use in the Q function. So we just set these to 0.3 and some random numbers, and we're going to test these parameters. Like these are like the graphs or like the plots that I showed you that we have tested in the end of the last video. So we're going to do this here as well in the next video, where we're going to test and tune the different kind of parameters here to get the best results for our agent when it's training. So we also set the learning rate here, which is how fast we want our agent to learn. And then we have the epsilon value here, which we're going to use for our epsilon greedy algorithm. So to tell the agent when it should explore the environment and when it should exploit the environment. And then we have an epsilon decay rate, because in the start we want to explore the environment a lot, and then over the number of episodes we want to explore less and less, and then we want to decay. So in the end we're only exploiting what we already know about the environment, and then only explore a couple of times. And then we have like some vectors down here for the test, where we're going to store some of the values, so we can output those here to a CSV file, and then we can actually like plot these values here in Python and Matplotlib to like try to tune the parameters and see like how the agent learns in the training process. So these are like the attributes here that we're going to use in QLearning, and we also have some of the functions up here, which I'm just going to go over and to give you an overview over what they contain. And then we're going to actually like do the implementation in code, which is done in the QLearning CPP file up here. So first of all, here we have a function to initialize the QTable. So to start off with, we just initialize the QTable with zeros in all the rows and in all the columns. And in the QTable we have the rows in the QTable represents the states or the rooms that the agent can be in, and then for each column it is the actions that the agent can take for a room. So we'll say like for example have index 0.0, then we're in then when we're in room 0, the action 0 that we can take is that index. So we're going to use the QTable here to update, like this is the QTable that we're going to update while training, and also what we're going to use when we deploy our agent in the end, where we have like found the optimal QTable. We also have this reward matrix that I talked about, which we're going to initialize with the different kind of predefined distribution of the rewards. And then we have a function here to just set an initial random state, so we spawn in a random room for every episode that we're training our agent on. And then we need some functions to take these actions and also get the actions from the current state that we're in. And then when we're in the new current state, we take a new action. So these are just like the functions that gets called for each episode. And then we also have a function here to run an episode. So one episode will contain different, like a lot of these function calls here, where it takes actions, it gets a new state, it takes an action from that state depending on the reward and the epsilon greedy approach that we take. And then we have the training process here, which just runs multiple of these episodes here for the number of episodes that we want to train our agent on. Then we can have a function here to display the train QTable in the end, so we know like does it actually like find the optimal QTable and which different kind of actions does it take when we're deploying our agent. And then down here we have a function to deploy our agent, which just uses the found QTable and just takes the maximum values in the QTable to take actions in the environment and try to maximize its expected return or reward. And then in the end here we have a function here where we can convert, like output our data to a CSV file, and then we can use that CSV file to plot our data with Python and Matplotlib to get like more visualization of how the parameters depends on each other, and also like how we can tune these parameters. So we're now into the QLearning CPP file here, and we're going to go over some of the functions here in this video, and then we'll cover the rest in the next video. So first of all, here we have a function for finding the kth largest index in a vector that we pass here as a parameter. So we're going to use this function here when we're going to implement our epsilon greedy approach or algorithm. So I'll come back to this one and we'll skip it for now, but it is just like so we can find like the kth largest index when we're going to take an action, because we don't want our agent to go back and forth between, like for example, room 10 and 9 just because it has learned that these rooms are good. We don't want our agent to re-enter a room and get stuck in that. So that's why we have this function here that we're going to use later on. So first of all, here we have this initialize the QTable, where we have this QTable init here, which is this QTable here that we just set equal to our private attribute here of the QLearning class, which is the QTable. So first of all, we just initialize this matrix here with 0.0. So now we'll just have a matrix with the number of rows which corresponds to the number of rooms we have, and then the columns is the number of actions that we're going to take. So this is a square matrix in this case here, because we have the same number of rooms and as the same number of actions in our matrix. So this is just to initialize our QTable here with zeros at all indexes, and then we set this QTable here equal to like the member attribute of the QLearning class, so we can use this QTable here later on in some other functions. Then the second function here is to initialize the reward matrix. So first of all, we have to initialize all the rooms that we have created. Like we have a structure for each room, so we're going to initialize an object for each of those rooms here, and then we need to pass the predefined number of like reward that we want to give to our room. So this is just the same rewards as I showed you in the previous video on one of the slides, where I had this map here where we had the different kind of rooms with the numbers, and also the predefined distribution of rewards for each room. So this is just the way we set it up here and initialize the reward for each room. Then we can go down here and get our reward matrix, which will just have a vector of one room, and then all the elements that it contains is the actions that it can take. So for example, in room 0, we have a -1 here where there's no connection. So if we're in room 0 here, it can't go to room 0 because it's already in room 0. So we have a -1 here. So the agent will learn that it can't go to room 0 when it's already in room 0. So that's not a valid action. And then for the first room here, it can go to the first room, and this is like actually like the only connection between from room 0 is to go to room 1. So to go to room 1 here, the action will have this reward here, which is the reward of room 1, and then the rest here is just initialized, or like it's just set to -1 because there's no valid connections between room 0 and all other rooms except for room 1. And the same approach is taken for all the other rooms, where the reward is just put in for the different kind of connections there is between the rooms, and all the -1s is the invalid connections between the rooms. So all the rooms here that has connections is the actual connections that the agent can go from one room to the other room. And then we're going to push back these rooms here to our reward matrix. So we have each room corresponds to the rows, and then all of these elements here corresponds to the columns and the actions that the agent can take. So this is the reward matrix here that the agent doesn't know anything about. And then when you're training our agent, we want to try to estimate this reward matrix here and with our QTable. And then when we have our QTable, this is actually like, it should be the same as the reward matrix here, and then we can go between different kind of rooms, such as taking the action which will return the maximum expected return. And then we have these two follow-ups here, which just sets like all the rooms here, we just check if the state, like the action for a given state, is equal to -1, and if it's that, we just if it's different from -1, we just set it that the number of actions plus plus, because then, for example, in room 0, it will have one number of actions because we can only take one action. And for example, in room 5 here, we have 1, 2, 3, 4, 5, 6 different kind of actions that we can take. So this is just these two follow-ups here. It's just running through our reward matrix and setting the number of actions for each room to the number that is actually like a connection to another room. So we can also get this random initial state here for our agent. So when the agent starts in each episode, it will just set to a random initial state, and that corresponds to a random room. So when the episode starts, it can either like spawn in room 0 or room 5 or room 4. Like it's just random initialized every time a new episode starts. So it will explore a lot more in the beginning, and it will learn faster compared to if you just spawn in one room. And it'll also find some more unique path between some of the rooms by having this random initial state. So it just takes this parameter here if it should be a random state, or if it just should be an initial state that we set by ourselves. So we have this random device here, so we're able to generate random numbers, and then we're going to create this uniform integer distribution, which is just called random state here. And then we want to return a random number from 0 to the number of states -1. So we will, in this case here, we will return a random integer between 0 and 10, and this will be the random initial state and the room that we can spawn in. So we know that we have the rooms from 0 to 10, and then this will return the random room that we're going to spawn in. So to give our process here markup property, we need to keep track of which room has been visited. So first of all, here we have a for loop that's just running from 0 to the number of states, and we just run through this by incrementing I. So first of all, we set the number of the room number to I. Like we just go through all the rooms now, and we set the room number to I, and we we initialize every room to be not visited. So we set this Boolean value here, or Boolean member function here of the room to false, because now it hasn't been visited, and then we will set it true when we visit that room when we're doing the training process. And we also set the number of visits here to 0. So this is just to initialize our different kind of parameters, or like our member function, or like member variables in our rooms, or like our states for this project. And then we check here, we have if statement here where we check if we should like return a random state, or if we should set the initial state to the state that we chose up here in the parameter. So often we would just take the random approach here, and then the initial random state here, which we're going to return and set the initial state for each episode. We set this random state here, which we created up here with this uniform integer distribution, and then we set this RD here, so we will not get like a pseudo random number, but we will get like a real random number with this random device up here. So this every time we run this function, it will return a new random initial state if this Boolean value here is set to true, which is often the case when we're doing the training. And then we've set the initial state like where we spawn our agent in the room. We set that room to be visited now, because we have now spawned the agent in a room, and then we set that room to visited, so it will not go back to that room again, because when we have visited a room, we will remove the reward. So this is more like the setup functions for our QLearning project that we're going to do here, where we're going to have an initial state, and we're going to initialize our reward matrix and our QTable. And in the next video, we're going to talk about like how we can actually like implement the functions of like how we can get an action, and also like how we can take an action in the environment. So there's a lot more between for this one here, where we're going to implement the epsilon greedy method and some other logic, and we're going to have this training process that we're going to implement. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification on the video, so you will get a notification when I upload the next video, where we're going to implement these functions that I just talked about in one of the upcoming days. And also like this video here if you like the content and you want more in the future, because it really helps out the channel and me in a massive way, and I just really appreciate your support. I'm also currently doing a computer vision tutorial with OpenCV and C++, and an algorithm data structures tutorial in C++ as well. So if you're interested in one of those, I'll link to one of them up here, or else on the scene next video, guys. Bye for now.